Hello students, welcome again. This is the third part of metals and non-metals. So in the previous part, we saw how metals and non-metals react with other objects such as water or acid. So now how do metals and non-metals react with each other? That is the topic of this video. Let's look into it. Before looking into it, we need to understand electronic configuration. So what is electronic configuration? Where a particular electron is in the atom. So, you know the atomic numbers of many of the atoms here. Helium, we have 2 atomic number. That is, it has 2 electrons and 2 protons. That is the meaning of the atomic number. Neon has 10 electrons, also equal number of protons. Electrons is equal to the number of protons. So what are electrons basically? They are negatively charged particles, and also protons are the positively charged particles. So you should know this is a balance. So when I tell they have 10 electrons and the 10 protons, that is their charge is balanced. So now we will take some of the metals such as sodium, magnesium, aluminum. Okay, these have 11 electrons. Sodium has 11 atomic number and 12 is magnesium, 13 is aluminum. Also some of the non-metals such as nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine. You can see their respective atomic numbers here. I will highlight these. Okay. These are the respective atomic numbers. So how these electrons are distributed in their shells? That is, they all do not lie in the same path or same plane. They lie in the, like our solar system. There is a nucleus here in between. Okay, and it has K shell, L shell, M shell and N shell. K, L, M, N. So these are the 4 shells. So the capacity of K shell is 2 electrons. It can hold 2 electrons. The capacity of L shell is 8 and so on. You can see here M has 18 and N has 32. So when I tell, let me erase it and show you an example how these electrons lie. Let's take the example of helium. So helium has very simple 2 electrons. Here 1 electron and here somewhere 1 electron. So these 2 electrons, the rest shells are completely empty. They are there, but they are imaginary. So the shells, these orbits, the circle which we are drawing is imaginary. So the only one shell is completely occupied. This is known as duplet stage. That is, its shell should be complete, then it is stable. If it is not complete, then it tries to make it complete. That is the nature behind every atom in our periodic table. So let us see about sodium. Now we have in K shell we have 2 electrons already. Now in L shell, here you can see sodium has 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So L shell has 8 electrons. Now we have 1 more electron in the M shell. So this electron is lonely, students. It is alone in its orbit, whereas it has the capacity of 18 electrons, but it is single in its object. So it tries to lose the electron because it doesn't want it to be alone. You can think of it like that.
Register today at KLM Institute for free online classes, revisions, doubt clearance, private online and offline classes, Olympiad exams, and win prizes, scholarships, and much more.
So now we will take an example of sodium and chloride. Imagine this is sodium and this is chlorine molecule. So here we can see the nucleus of an atom, and we know sodium has 11 electrons. So 1, 2 in the first shell, that is K shell. Here we will draw circle so that you can remember it easily. Okay, electrons, 1 electron, 2 electron, 3 electron, 4 electron, 5, 6, 7, 8, 9, 10, and one more will be in the next shell because the capacity of this shell is full. So I hope you got it. Where are the electrons here? Now in the chlorine molecule, let's check our previous table here. In our chlorine molecule, we have 17 electrons. Okay, the atomic number is 17, hence the number of electrons will be 17. In the K shell, it has 2 electrons because the capacity is complete. And L shell has 8 electrons. And in the M shell, it has 7 electrons. Let's try to fill those. Let's take circle itself. Sorry, you should always start filling the electrons in the least energy shell here, closest to the nucleus of an atom. Here we have 2 electrons. I've drawn 2 electrons in the K shell. This is M shell, which has 8 electrons. So 4, 5, 6, 7, and 8. So how many electrons are remaining? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. We should add 7 more. That will come in the next shell, that is M shell. 1, 2, 3, 4, 5, 6, 7. But the capacity of this shell is 18. If it is 8, if this shell has 8 electrons, still it can be complete. Why do I tell this? This is the rule of octet, students. In the outermost shell, there should be 8 electrons in an atom. So if we remove this particular atom, let's take a different color. If we remove this atom, that is this electron from sodium, and if we put it in the chloride ion, which becomes complete. Its outermost electron will be 8 here, and this outermost valency shell has 8 here. So let's, just for clarification, now we have 7, it has 1 electron in the outermost shell, and it has 7 electrons in the outermost shell. Remember students, this is the just outermost shell which I am talking about. It's not the complete set of electrons. So what happens when sodium loses an electron? Here I have an electron of sodium. It will just lose it. Okay, it will lose it, and okay, this is the lone electron. Now sodium gets a plus charge. Okay, sodium has a charge now. It was a neutral atom because the number of electrons should be equal to the number of protons. Now it is not equal to the number of protons. What is more here? Positive charge is more. How many? 1. So we have Na plus 1. If you don't write any number, it's usually 1. And here, this same electron, if you are adding somehow to the chlorine molecule, it becomes minus because the number of protons are not changing. Only the number of electrons are changing. And electrons are negatively charged particles. So as you add one more electron to chloride atom, it becomes Cl minus, it becomes an ion. So these are ion, you can see here. Here Na has 2 in the first, 8 in the second and 1 in the valence shell. Last shell is known as valence shell, student. If you remove this one electron aside, it becomes 2 and 8. It became a octet structure. It is happy now. Okay. Chlorine has 287. As you add one electron to it, it becomes 288. Again, the outermost shell has 8 electrons. It is again satisfied now, but it has a charge. So to negate that charge, it should give, it should make a bond. So what is this bond called? This bond is something known as ionic bond, students. So what is ionic bond? A bond between, you can tell simply, a bond between a metal and a non-metal is ionic bond. Or you can also call this bond as electrovalent bond. That is not necessary to remember, but it makes more sense. Electrovalent, that is, electrons in the outermost shell are transferred from one atom to another atom. That is, we can see one more example here. First, we will see the electronic configuration of magnesium. It is a metal, student. It has 2 in the first, 8 in the second, fine. But in the last valency shell, it has 2 electrons, whereas it should be 8. So now we will remove 2 electrons out. Now it becomes a cation. So whenever an element such as magnesium gets a positive charge, it becomes cation. Cation is positive. Remember that, students. And chlorine molecule, it wants electron. It is electronegative. It wants one more electron badly because it has to complete its octet structure. Again, it will gain an electron, but it has only capacity of 1 electron. So two chlorine molecules join in the magnesium. So they make, magnesium gives an electron to one element of chlorine and one more to the other element. So here you can see here Mg2 plus and Cl minus, that are two elements of Cl minus. So these both form a bond known as ionic bond. So this is a very strong bond. You can have other examples such as sodium chloride, as I showed you. Okay, NaCl is such an example. And also all the metals of the first column and all the non-metals of the 17th column, these both are very likely to make a ionic bond because the 17 requires one electron to complete its octet structure, and the first period requires to lose one electron. Okay, so ionic bond, a type of linkage formed between electrostatic attraction between oppositely charged ions in a chemical compound. So when I tell oppositely charged, what are these oppositely charged? We have Mg 2 plus and Cl minus. So these are oppositely charged, and you know opposites attract. So you can also take the example of sodium, which is very simple. Sodium Na plus and Cl minus. So these are oppositely charged molecules. So there will be an electrostatic attraction there between the two bonds. This attraction is known as ionic bond, students.
Give your imagination wings. If you're willing to write something, what are you waiting for? Share your ideas and thoughts. Let your ideas reach out to millions. Get your articles published through our blogs for free.
So now let us study what are the properties of ionic bond. So its physical nature is very simple. You can see here, this has only 4 points, students. You can remember it very easily. Ionic compounds are solids. So you can take one example and remember all this. NaCl, it is a solid and are somewhat hard. You cannot break out NaCl very easily. Okay. And it has a strong force of attraction. Please remember this, because the positive and negative ions are very eager to get the octet structure. These compounds are generally brittle and break into pieces when applied pressure. If you take a rock salt and crush it, it will easily break into smaller salt compounds. Okay, and it has melting and boiling points which are fixed. Ionic compounds have high melting point. Okay, it has high melting point and high boiling points. I will show you some of the examples. This is because a considerable amount of energy is required to break these bonds. It is not easy to break such a strong bond because it wants to be in the octet structure. It does not want to get out of it. And solubility, it is where you can write it easily. What happens when you put salt in water? They are generally soluble in water. So such as sodium chloride, MgCl, all the salts are generally soluble in water, but they are not soluble. Try this at home. You put salt in petrol, kerosene, something like that, but with an adult supervision. It is not soluble in such solvents. So here I have written down the ionic compounds and their melting and boiling point. You can see such an high temperature NaCl, just our table salt has. That is 1074 Kelvin, students. That is really high, and 1686 Kelvin is the boiling point of NaCl. You can see the others here: lithium chloride, calcium oxide, and MgCl2. These all have very high boiling point and melting point. So one more very important property of ionic bond is, we already know they are soluble in water. You can add a salt, you can make a salt solution very easily. Also, because they have ions in them, because they have Cl minus, for example, NaCl is a neutral compound, but when you add it to water, it breaks down to again Na plus and Cl minus. So these ions help the electricity to pass through. Here we have illustrated a small experiment. The conduction here with regular water is lesser than what you add to if you are adding salt to water and trying this experiment, it will be higher. The conduction of the liquid solution here, it will be higher. That is what the theory part of it is given here. You can go through it. And I hope I have made you understand this very clearly about the ionic bond. Thank you, students. We will meet in the next part.